Okay, folks, so last week, DeepSeek was the first model to score a perfect 100% on every single task I threw at it. Today, Google has done it with Gemini 2.5 Pro. On top of that, Gemini 2.5 Pro has also scored the highest on the complex OCR task that I have. So out of the 100 questions across 5 different tests, there's just one question that's keeping Gemini from absolutely crushing it on every single one of my tests. Stick around to the end of the video to see what that question is. Given that R1 does not support vision, I have to say Gemini 2.5 Pro is the current champion, at least of all of my tests. And stick around to the end of the video. I'll show you the complex OCR task. This is a very, very hard task, and I'll show you how difficult it is and how few models even come close to accomplishing what Gemini 2.5 Pro has done here. I have to say, something has happened inside Google that has fundamentally shifted the trajectory of their AI progress. Barely 6 months ago, they were trailing behind OpenAI and Anthropic, and now they're the ones leading the pack. What is also amazing is that they don't have to pay the NVIDIA tax because they have their own TPU infrastructure. Their per token cost is the lowest in the industry and have a strong feeling that they're going to crush OpenAI and Anthropic in the next few months, not just in model capabilities, but also on price. Let me show you the pricing. This is all public information, but when I show you a chart like this, it puts things into perspective. As you can see, Gemini 2.5 Pro is $1.25 per million for input and $10 per million for output. Sonnet, not even Opus, Sonnet is double that on input and much higher on output. And O3, which would be the corresponding OpenAI model, is significantly more. $10 per million for input and $40 for output. I also put Flash here because I'm going to show you as a part of this video how Flash performs with some of my tests, so that it'll help you make that determination whether the price performance ratio of Flash is a good value for you. So without further ado, let's get started. Before we continue, I would like to ask you for a favor. As you can see, we are a very new channel with a small number of subscribers. So if you enjoy our content, please consider subscribing. It costs you nothing and it helps us grow. Also, check out our website promptjudy.com. You can sign up and create your own custom evaluations, or you can look at community evaluations for a wide variety of use cases. We have published hundreds of evaluations and are releasing more every week. If there's one thing that you take away from this video, please let it be that you should be testing your own prompts with your own data to see what works best for your use case. Prompt Judy helps you do just that. Now, back to the video. So if you've seen some of my videos before, you already know what this test is. But if you're new, this is a very simple test. Many models get a perfect 100% on this test, so it's no surprise that both Flash and Pro get a perfect 100% on this test. Let me quickly show you what the prompt looks like. Essentially, what we're asking the model to do is, given a particular question, does it match any of these criteria? Is it harmful? Is it manipulative? Is it inappropriate? Does it attempt to leak system instructions and some false positives? And we ask the model to respond with either harmful or not harmful. You can go through this list of questions. They're linked in the description below. But no surprise, both Flash and Pro score a perfect 100% on this test. So the next test is the named entity recognition test. This is a structured JSON extraction test, and the instructions are as follows. You are a specialized named entity recognition system. Your task is to process input text and extract specific entities with the following rules. We tell the model to extract people, keep the names in the original language, locations translate to English, organizations translate to English. We do this because the location and organization is used to populate an SQL query, and the data is stored in English. We tell the model to follow the specific requirements for people, extract and separate first and last names, ignore middle names. For locations, break it down into city, state, and country. We want the country code to be in ISO format. For state code, we only want US and Canada. For all others, we want international. For organizations, we want to remove legal entity terms. We want to handle multiple entities. We want to correct any misspellings. We want to preserve the original language for person names. The evaluator here is a JSON evaluator. So it compares the model's output to the expected output recursively for each attribute in the JSON. Even if a single attribute is wrong, the score is 0. So this is a very strict test. A couple of years ago, even the best models scored below 50% on this test. But today, as you can see, multiple models score above 90% on this test. So this is a particularly difficult test. The only two models to score a perfect 100% on this are Gemini 2.5 Pro 0605 and DeepSeek R10528. And as I mentioned in the description of the prompt, this is also a very strict test. Make a single mistake in a single JSON attribute and you get a 0 score. But also on top of that, there are so many rules that you have to follow when you make this JSON. So as you can see, Gemini 2.5 Flash actually did pretty good on this task as well. Let me show you the one mistake it made. And I also, I think it's a stretch to even call this a mistake. So all it has done is it took this bank name, Santander Bank, and translated it. In the question, the name of the bank is Banco Santander. This is actually, I don't know. I'm torn on this. However, both models, both Gemini 2.5 Pro and 2.5 Flash, I think they've done a tremendous job on this test. And this is a particularly hard test. I think even Sonnet and 4.1 scored a 90 or a 95 on this. So this is a brilliant score. So now this is the SQL Code Generation Test. The prompt is as follows. You are a specialized SQL query generator system for SQLite database. Your task is to process input text and generate a valid SQL query based on the provided schema. Then we give it the following rules. Generate select statements only. No insert, updates, or deletes. Return not allowed for DML. Return not possible if the question can't be answered. Only reference the table that exists in the schema. Respond only with the SQL query. Respond with appropriate joins. All data is stored in English. We give it the following schema, and then we give it the question, and we give it some examples. The evaluator here is a code evaluator, so it actually runs the generated SQL statement and compares it to the output, to the expected output. So this validates that the SQL is not only syntactically correct, but also produces the desired results. And again, a lot of models score a perfect 100% on this test. Claude Anthropic has always been strong on this test, but now with 4.1 and the reasoning series from OpenAI, they're also catching up. And then there are open models like DeepSeek and Qwen that also do very well on this test. So this is one of those tasks where I think it may be worth paying for 2.5 Pro over 2.5 Flash. As you can see, 2.5 Pro has scored a perfect 100%, 2.5 Flash has scored 95%. Let me show you the mistake that 2.5 Flash has made. As you can see, it has created invalid SQL statements. And I ran this a couple of different times, and it consistently made an invalid SQL statement. So I think this is a weak point of 2.5 Flash. Gemini 2.5 Pro 0605 is actually the first Gemini model to score a perfect 100% on this test. Sonnet 3.5, 3.7, and 4 has always scored a perfect 100%. The Qwen series of models, even the smaller ones, I think the 14 million, also scored a perfect 100% on this test. 4.1 from OpenAI scored a perfect 100%. As you all know, OpenAI has made significant improvements in coding with 4.1. They acquired Windsurf, so they're focusing more and more on coding. Anthropic as well, with the release of Sonnet 4, their focus was heavily on agentic coding. And I think there is a market here for these LLMs to grab market share. by being better and better at coding. So the fact that we're seeing improvements across the Gemini iterations, I think is very encouraging. If you're using Cursor or WordSurf, I would highly encourage you to try 2.5 Pro and tell me what your experience is like in the comments. I'm very curious to hear. And then the final test is the Retrieval Augmented Generation Test. Let's look at the prompt. You are a specialized AI assistant tasked with answering questions based strictly on the provided context. Follow the following rules. Use only the data within the given context to answer the question. No outside knowledge, assumptions, or information not explicitly stated in the context. Respond in the original language. Include citations, the format of the citations. If the question is completely unrelated, say, I cannot answer this. If the question is somewhat related, provide the relevant information from the context, respond in Markdown. And then we give it the format, then we give it an example, and then we ask the question. One of the biggest things that we're trying to look for in this test is how the model handles trick questions, questions that are about things that are not in the context, or questions that are tangentially related to the context but do not have an authoritative answer. We want the model to follow instructions and say it can't answer the question rather than providing a wrong answer, or an answer that is an opinion, not a fact based in the context. I have found that some of the reasoning models struggle a little bit here. But again, there are a number of traditional non-reasoning models that do quite well on this test, both open source and commercial. So for the Retrieval Augmented Generation Test, I think both models have done just fine. Gemini 2.5 Pro has scored a slightly higher 99%, and 2.5 Flash has scored slightly lower at 97%. But the mistakes that they've both made are very, very minor. Let me show you one of these mistakes. Like the question here is, why is O1 the best model? If you look at the answer, both models are correctly saying that the context does not say that a single model is the best. The points are being lost, however, because it has included references that it hasn't used. It has only used the second reference, which is the DeepSeek paper. These other references are unnecessary. Interestingly, the 2.5 Flash made the same exact mistake. So as you can see, these are very minor issues. I did want to talk a little bit about this question, though. A lot of models get this question wrong. This question is, why is O1 the best model? And many models, by the way, including some of the commercial models, will try to justify a yes answer to this question. One of the characteristics of a strong model is for it to say that the question doesn't make sense or that you're wrong when it has information that supports that argument. So here, it has clearly looked at the context and found no fact in the context that says this is the best model. And it has come back and said so. Right? So I think, this is, and if you go through some of these other questions, I've put in some trick questions. This is another example. What is the performance of O1 on the MedQA US Emily 4 options dataset with zero-shot prompting? Now, the trick here is that O1 isn't listed in the dataset in the context. GPT-4o is. So the model has to be smart enough to tell you, hey, I don't see O1 in this list. I see GPT-4o. Many models, including some of the commercial models, will attempt to answer this by saying, you said O1, but maybe you mean GPT-4o, and they will try to give you a yes answer. However, I'm very pleased to see that both Gemini models correctly say that the answer doesn't exist. You can go through some of these other questions. I've carefully chosen them to be tricky questions. And, the fact that Gemini 2.5 Pro is scoring a perfect 100% on this is pretty encouraging. So before we get into this next test, I want to take you back to the statement that Sam Altman made a few months ago, where he said deep research can automate a single-digit percentage of all economically viable tasks in the world. When I first heard this, I chuckled a little bit because so much of what we do, especially in entry-level office jobs, is reading and analyzing documents. These require vision, they require understanding documents, deriving insights from them, summarizing them, extracting information, and producing more documents based on these insights. However, up until a few months ago, the LLMs, even the frontier ones, were laughably bad at this task, which is why I didn't take Sam Altman seriously. But I would like you to take a moment and truly understand this next test I'm about to show you and extrapolate from here what it means for the economy when LLMs become so good that they can read entire reports and produce artifacts that today many people, especially in entry-level roles, do. And then when I saw this article about Dario Amodei's views regarding AI's impact on future employment, it makes me wonder where all of this is headed. We're already seeing in the news that AI is having a noticeable impact on the entry-level job market. So I think this next test is just an additional data point that gives credibility to this view. So this is my complex OCR test, and I have to say this is probably the most complicated test that I have. In fact, I don't think any model has been able to score a perfect score on this test. Though in theory, this is not a very hard test. We know a majority of the frontier models today support vision. This test essentially puts that capability to its basis. What we want to do here is to take a snapshot of a page from a PDF document and convert it to semantic HTML that is easily consumable by smaller LLMs. You may ask, why not send the snapshot of the page directly to the LLM at inference time? Well, there are two reasons for this. First is limited vision support. Not many smaller LLMs support vision. Second is the performance issues. Even the larger models that support vision struggle a little bit to answer questions from page snapshots compared to the equivalent textual representation of the same page. So this approach allows you to run the document through a very strong and large and even slow reasoning-based large language model during ingestion, because that's a one-time process, and then use the equivalent semantic HTML or Markdown with a smaller, cheaper, or local LLM for inference. This gets you to both worlds where you're able to ingest complex documents with charts and tables and images, accurately represent the information contained within them, and then use smaller models that are not expensive at inference time. As you're aware from my Retrieval Augmented Generation test, even smaller models like the Llama 8 billion models, the Qwen 4 billion and 8 billion models, the Gemma models, do a great job with Retrieval Augmented Generation if you give them well-structured context and textual format. That said, let me show you what some of these pages look like. So as you can see, this is a chart, a pretty complex chart I may add, and we are trying to convert the information within this chart into tables. So this right here is a page from a financial report. This is actually a pretty common format in financial reports. They have tables with multiple levels of columns and then multiple levels of rows. And then the LLM has to infer the corresponding HTML structure. A pretty complex task, in my opinion. And then moving on to the next one. So this right here is, again, a table with multiple levels of rows, hierarchy, and some infographics. Moving on to the next one. This one is a timeline, clearly for it to be able to translate at inference time, for the LLM to be able to understand what year belongs to what text. It needs to have a structure like this, either a table or maybe a section-by-section markdown or something. Moving on to the next one. Again, a financial table. Very common in financial reports to have multi-level columns and then hierarchical rows, and the LLM has to make sense of it when it makes the table. moving on to the next one. This, I think, is among the most complicated pages. As you can imagine, it has to go through section by section. It has to identify, all the charts within that section, and then the corresponding tables, and then another chart, and then go through and make corresponding tables, and then group them in a way that it makes sense as the page flows. As you can imagine, this is a pretty difficult task. Right. And then this final one, this is also a relatively difficult page to process. If you can see in the top section, all these charts, not all of the charts have the legend. So it has to look at this first chart, and then remember, that's the legend. As it's processing the rest of the charts, it has to keep that legend. And then there's another section about additional infographics and numbers. So overall, this is a pretty difficult task. And, at least as of this recording, very few models have been able to score a very high score on this test. So as you can see, 2.5 Pro 0605 is the top scoring model on this very complex task. In fact, there is just one question that's keeping 2.5 Pro from acing this test. As you can also see, 2.5 Pro is beating 2.7 Sonnet, OpenAI's model, all the other open source models. And in fact, this might come as a little bit of a surprise. Sonnet 4 actually traces even Sonnet 3.7 in terms of performance on this test. I think Anthropic has made it pretty clear that they're primarily focusing on coding performance, especially with long duration coding performance. But I would have expected that their performance on other tasks wouldn't have regressed, but that's what seems to have happened here. And honestly, OpenAI was never really good at this task. In fact, it's scoring lower than even some of the more open source models from Quen and Mistral even. So let me show you the question that is keeping 2.5 Pro from acing this test. It's this one right here. So let me show you the artifact, and let me show you the small mistake it's making. Also, this also points to one aspect of this test. We have a very strict scoring mechanism. For us, if the model makes a mistake in a number or how the number is being represented, it's a straight 0. We primarily develop solutions for financial services. As you can imagine, if you read a financial report wrong, in fact, even if you're developing a solution for, let's say in medical services, and you're reading somebody's, blood report or something, and you read the chart wrong, the consequences of that can be pretty severe. So that's why we've put this baseline criteria that every single number that's being represented has to be accurate. So if you can see, there is a very, very small mistake here. What it has done is for Europe, it has said 3398 and 3790, where in fact, Europe should have been 3790, as you can see here, and Middle East and North Africa should have been 3398. So it has reversed this. This is really the only mistake it has made, right? And if I show you some of the other models, they're making significantly more mistakes. So I don't know, is Gemini going to be the model that aces this test in the future? Maybe the next version of it? Who knows? But I can't wait to find out. In the meantime, I hope you enjoyed this video, and I will see you again in the next one.